So here are the answers to that exploration. Again, we notice that if you make it a negative natural log of x, it just reflects across the x-axis, right? So your x-intercept is the same. If you make it natural log of negative x, the x changes across that y-axis, the asymptote's still there. And if you make it negative natural log of negative x, the end behavior is that one different, right? It's going off left and down versus this is going left and down, this one's going left and up, this one's going right and down, this one's going right and up, right, is that idea. So that end behavior is really what's happening here. Versus, of course, when I look at the quadratic, it's the intercepts that are going to be evident, right? So when I make just the y negative, all of the signs change across, right? But your x-intercepts stay the same, it's just your y-intercept that moves down. When you plug in the negative into the function, notice only things that had an odd number are changing, that odd degree, are changing. It reflects it across that y-axis, your x-coordinates, your x-intercepts flip-flop across the axis. And then, of course, when you make both of them true, both intercepts become opposite in the x direction and in the y direction. So given the point negative 3, 5, find the image of the point under the transformation. So this one is a reflection, and it's reflected, y is changed. Really, this is going to be multiply y by a negative, right? So when I take that, it's reflected across the x-axis. If I ask you to describe it, I really just make y negative. So it's already got a negative 3, I just make my y negative. This one I'm changing my x. Really what's happening is I take my x and I multiply it, right, my x coordinate, and multiply it by a negative. You can think of it as dividing by a negative if you want. The y is not being changed. That's your reflection across the y-axis. And this one is, of course, both. You make both of them opposite of what they started as. So notice when I ask algebraically to find the new equation for g of x, was f is reflected to get to g. So I take f and I say reflected in the x-axis. And if I'm going across the x-axis, I'm changing my y's, so I make it negative f of x. Again, I like seeing this step, so I know that you are attempting to do the right thing. Now I know that you can take this whole f of x and plug it right in there, and that's going to be the opposite sign on everything. Versus this guy says the function is reflected in the y-axis to get to g of x. If I reflect across the y-axis, I'm making my x's negative, f of negative x. This one I do want to show the workout just to make sure that we put these in parentheses correctly. Of course, that doesn't really need to go in parentheses, this one. In reality, this one doesn't need to go in parentheses anymore. You're just adding that negative. What really has to go in parentheses is this, because make sure when you put a negative to an even degree, that's going to get squared out and still be a positive. This is, of course, minus. And this is, you can keep it as e to the negative x. We know that's the same thing as if I write it as 1 over e to the x, right? So either of these would be valid for that g of x.